Today I'll be presenting my research about the effect of generosity and vulnerability on conditional cooperation. Prior to studying the research, I read behavioral economic journals and papers that talked about how real-life human behavior often deviates from what is predicted by economic models, and this cites numerous factors, including social preferences such as altruism and reciprocity. But today specifically, we're looking at generosity and vulnerability, which vulnerability has been studied in a psychology context before, but never in an economic context. So in social relationships, self-disclosing behavior and intimate behavior often fosters a sense of trust. And we want to see if this is also the same in an economic context. So our three research questions, the first one being, does generosity have an effect on conditional cooperation? The second one looks at whether vulnerability has an effect on conditional cooperation. And the third one being, do predictions of behavior correlate with an individual's decision making? So my answer to all three of these research questions were yes. Generosity would have a positive effect on a person's willingness to cooperate because people take into account their prior experience. So if someone is kind to you, you would want to reciprocate that kindness. For the second research question, vulnerable behavior would have a positive effect on the recipient's willingness to cooperate because the vulnerability signals trust. And this has been shown in social relationships. So we're seeing if this would also show true in an economic context. The last one being, yes, players would determine their strategy based on what they assume their counterpart would play. So in order to tie all three of these research questions under the same game design, I had to design my own game, which was a two-stage game that followed the other, and players knew this before entering into the survey. So the first game is, this is the payoff flowchart for player one, and player one has two choices between A or B. If player one chooses A, he or she gets 75 cents, and the second player, player two, gets 25 cents. And player two basically has no choice in the payoffs whatsoever. But if player one chooses B, then player two's choice does matter. So player two gets a choice between C and D. And if player two chooses C, then player one will get 25 cents and player two gets 75 cents. If player two chooses D, then player one gets 100 cents and player two gets 50 cents. So essentially, strategy A for player one is the safe choice because the payoffs are already set. It's guaranteed that player one gets 75. But if player one chooses choice B, this is an indication of vulnerable behavior because they have a chance to be harmed by player two. So this is just the same game in player two's perspective. If player two chooses C, he or she is essentially harming player or taking advantage of player one's vulnerable behavior. If player two chooses D, then he or she is rewarding player one's vulnerable behavior. And it's important to note that if player one chooses A, then player two will never have the chance to get a payoff higher than 25. So in a way, player two is rewarding player one's act of generosity as well as vulnerable behavior. And after game one, we'll look at game two, which is a prisoner's dilemma game. This is to see whether what has happened in game one affects the level of cooperation in game two, because if both players choose F and F, this is the socially optimal behavior, which is when both players are cooperating. Whereas when both players choose E and E, it's when no one is cooperating and people are distrustful of each other. So the Nash equilibrium in these two games, in game one, it would be A and C, which would be the selfish and safe behavior. In game two, it would be E and E, which is also the selfish behavior. But we're expecting that people would choose B and D in game one, and consequently F and F in game two, because they are being rewarded with their vulnerable behavior and generous behavior. So after we designed the game, we put them onto Google Forms surveys, one for each player. And the introduction to the surveys was just a summary of what they would be doing as well as what bonus they would get. For player one, the first question was whether they would choose A or B in game one. And all of these questions were asked after they were being introduced to the two games. So they had complete knowledge of which games they would be playing before they were asked about their decisions. Depending on what player one chose in the first question, they would be directed to a different part of the survey. So if they chose A, the next question would just be, do you choose E or F in game two? But if they chose B, they would be directed to a scenario about their choice in game two, considering whether the player two chose C or D. And then after these, questions 4 and 5 are asking about player one's predictions, which is the same regardless of what they chose in question one. For player two, it's the same survey for everyone. The first one being, suppose that your counterpart chooses B in game one, do you choose C or D in game one? And then suppose that your counterpart chooses B in game one, do you choose E or F in game two, as well as what would you choose in game two if your counterpart chose A in game one? Then questions 4 and 5 is the same, which are predictions of what they think player one would choose. And these surveys were distributed on Prolific, which is an online platform that is able to get a standardized sample. So I entered the two surveys as two different studies under the same game, and this was to prevent the same people from playing in the same study. And then so this is just a snapshot of the flat pay rate as well as the medium time of completion. I aimed to get about 100 responses for each player, but I ended up with a little bit more than that, so that was also fine. Now looking at the results for player one, 70% of player one chose A in game one and B in game two, where A is the safe option and B is the vulnerable option. And then looking at game two, where player one chose A in game one, about 42% chose E and 58% chose F. This is where E is the selfish option and F is the cooperative option. Then looking at if player one chose B in game one, about 45% chose E and 55% chose F on the conditional that player two chose C. And then this is about the same as when player one chose A in game one, which is what we expected. However, when player two chose D, about 19% chose E and 81% chose F. And choice C is when player two takes advantage of player one's vulnerable behavior. But choice D is when player two rewards player one's vulnerable behavior. And we can see that these results are slightly different from each other. And as for the predictions, they generally aligned with what actually happened. So that was interesting to see. Now going to analysis of player one, we did our analysis through binomial probability, which looked at the chance that something would happen due to pure chance instead of some outside factor affecting it. So we wanted to see whether player two's generosity had an effect on player one's conditional cooperation. We wanted to see whether there was some type of reciprocity going on. So we did a binomial probability analysis on the number of choice differences in game two, depending on whether player two chose C or player two chose D. And we got a p-value of 0.011, which is less than 0.05. So we concluded that there is a statistically significant change in behavior, and it was not due to chance, it was due to some other factor. Now looking at the results for player two, about 49% chose choice E if player one chose A, and 51% chose F. If player one chose B, then about 50% chose E and 50% chose F for player two. And these results don't really differ from each other. Now just looking at the predictions, player two's predictions of player one behavior were slightly higher than what had actually happened. Now, on analyzing player two's results, we want to know whether player one's vulnerability had an effect on player two's conditional cooperation. Is there some type of trust being formed? And there was a 50-50 split between choice E and choice F, regardless of what player one chose in game one. So our answer to that was no, there is no statistically significant change in behavior. However, we came up with one additional observation, which was not what we were originally intending to study with our research questions. This was due to player two's change in behavior between the two games. So 10 participants in player two chose D in game one and E in game two, which is a change from generous behavior to uncooperative behavior. Now, about 29 participants chose C in game one and F in game two, which is a change from selfish behavior to cooperative behavior. And we wanted to see if this was, something due to chance, or perhaps there was some other underlying factor going on. So we did a binomial probability analysis, and we came up with a p-value of 0.002, which is less than 0.01, so there is a statistically significant change in behavior. Why is this so? We attribute it to inequality aversion, which are people not wanting to be less than their counterpart, even though this might make them more well off. It is so there's a degree of uncertainty in the inequality between the players' payoffs, which can matter if people feel averse to disadvantages inequality. So in game one, D is definitively better off for player one and worse off for player two than C. However, in game two, player two is still worse off from choosing F, yet there is uncertainty about the relative worseness because he could be the same amount as player one. And possibly this uncertainty leads to more cooperative behavior. So in order to get a more well-rounded conclusion of this, a follow-up experiment would be needed, where we would have to change the payoff for choice D to an equal payoff to make player two, to see whether player two would choose C and D. Now, in conclusion, conditional cooperation exists, especially when people are rewarded after displaying vulnerable behavior. Yet vulnerability is an unlikely factor in conditionally cooperative behavior. And for our last research question, player predictions are generally consistent with their playing strategies, so they are correlated. Thank you so much.